Hello guys, in this video we will talk about a new lesson which is areas. This lesson is one of the most important lessons in our subject, and we will learn how to calculate the area of any shape we have. If we have a shape like this and we want to calculate the area, we will learn how to calculate a regular and irregular shape like this. To calculate the area, we have two methods. First, we have an instrumental method by using computer softwares like AutoCAD or by using planimeter. This is the planimeter. This device can calculate the area of irregular shapes that drawn in maps. And the second method is the mathematical method, and we will talk about the mathematical method in this video. The mathematical method divided into three types. First, the regular shapes. Second, the polygon areas, and third, the boundary area. In this video, we will talk about these two types of area, and the next video, we will talk about the boundary area. First, we have the regular shape, like a rectangle or a square. If we have here a rectangle, this rectangle width is, we call it B, and the length we call it L, so the area of the rectangle equal BL. And if we have the square, this all side is equal, this side is B and this side also is B, so the area of this square is B square. The second type is a triangle. The triangle, we have the three formula to calculate the area. The first formula, if I have the base of the triangle and I have the height which perpendicular on this base, so the area will be equal 0.5 BH. This is the first formula. The second formula, if I have two lengths of the triangle, if I have L1 and L2, and I have the angle between them, angle theta, so the area, it will be 0.5 L1 L2 sine theta. The third formula, if I have the three lenses of the triangle, L1, L2 and L3, the square root S minus L1, S minus L2, S minus L3, where S equal L1 plus L2 plus L3 over 2. This is the second regular shape, is the triangle. The third regular shape is parallelogram. If I have L1 and I have L2 and I have the theta between L1 and L2, so the area, it will be equal L1 L2 sine theta. Or sometimes I have L1 and I have H. H is the perpendicular distance from L1 to the height. This is H, so the area will be L1 multiply H. If we have here rhombus, the rhombus characteristic is the two diagonals is perpendicular on each other. If this point A, B, C and D, so I have LAC and I have LBD, so the area of this shape equal 0.5 LAC LBD. The trapezium, if we have here the lower base and the upper base, and the upper base and lower base is parallel to each other, this is B1 and this is B2, and I have the H between B1 and B2, the H is always perpendicular to these two bases, so the area of trapezium equal B1 plus B2 over 2 multiplying H. And sometimes this basis may be in vertical way like this. This is B1 and this is B2, and this is the vertical distance between B1 and B2, so the area is the same equation. The last shape here is circle. If we have the circle and we have the radius R and we want to calculate the area, so the area it's equal by R square. And if we want to know the area of a sector of a circle, this sector make an angle, we call it theta, so the area equal pi r square theta over 360 degree. And if we have here a hollow pipe, the hollow pipe we have inside diameter r in and we have outside diameter r out, and we want to know the area of this section, so the area equal pi r out square minus r in square. And if we want to calculate the area of this sector of this pipe, this sector make an angle, we call it theta, so the area equal pi r out square minus r in square theta over 360 degree. If we have a regular pentagon or hexagon or hectagon, first we should divide this shape from the center into a triangles. We will divide it into triangles like this. So this triangles is equal triangles. So if we can calculate the area of any triangle, so the total area total equal area multiplying number of the triangle. Here for the hexagon, we also divide this shape into equal triangles. And if we can calculate the area of one triangle, so the area total equal area multiply in number of the triangles. We have also the ellipse. The ellipse have two diameter. The ellipse have two radius. This is the first radius, we call it A, and this is the second radius, we call it B. So the area of the ellipse equal pi multiplying AB. This is the area of the ellipse. The second type of area is the polygon area. What is the meaning of polygon area? Polygon area, it's any shape with straight lines, and it's not regular shape. It's irregular shape. So this shape, this is point A, and this is point B, point here, point C, and here point D. And some way I have the coordinates of point A. I have XA and YA given, and the coordinates of point B also given, XP and YB given. Here point C, XC and YC given, and point D here, XD and YD also given. And I want to calculate the area ABCD. First, you should choose a starting point. So I will choose a starting point A. Someone else will choose a starting point B or C. It's no different. So I will start with point A, and you should choose a direction. So I will choose a clockwise direction. Someone else, he can choose anti-clockwise. It's no different between the clockwise direction or anti-clockwise. The area of this shape equal half multiply in, and between two brackets you put here the first point you choose. I choose point A, so I will put here point A. After point A, it will be point B, and point C, and point D. And finally, you must put point A again, because it's a closed polygon. So you start from point A and go to point B and C and D, and you must, to close this area, you must come back again to point A. We will write the coordinates of each point as a fraction. Here we will put the X coordinate, and here we will put the Y coordinate. For point B, we will make the same. Here XB over YB. For point C, XC over YC. For point D, XD over YD. For point A, XA over YA. Then the first diagonal will multiply together. XA multiply YB plus XB multiply YC plus XC multiply YD plus XD multiply YA. So here in the first, XA YB plus XP multiply YC plus XC multiply YD plus XD multiply YA. This is the first diagonal. The second diagonal will be by minus. So this bracket minus the second bracket is the second diagonal, XA multiplying YD, XD multiplying YC, XC multiplying YB, and XB multiplying YA. So here XAYD plus XDYC plus XCYB plus XBYA. And we will close the first bracket we put here. So let's take an example. Calculate the area of the closed polygon ABCD if the coordinates of its corner are as shown below. This is the coordinates of each corner. The area equal half multiply in. We will put the first point here. I will choose the first point A. The following point is B, C, D, and I must end this point with the first point again. So we will put here point A. And we will write the coordinates like this. The coordinates of point A is 0, 0. The coordinates of point B, 34.39 to the west. To the west, it's meaning minus. So here, minus 34.39. Over 34.39 to the north. To the north, it's mean by positive. So here, 3.39 by north. Point C here, 51.5 to the west. To the west, it's mean by minus. So here, minus 51.5. And here, 13.01 to the north. To the north is positive. Here, point D. To the west is minus and to the south is also minus. So point D, negative 12.07. And here, minus 15.1. And coordinates of point A is 0, 0. We will multiply the first diagonal. And then we multiply the second diagonal like this. So it will be equal half multiply in first diagonal minus the second diagonals. The first diagonal here, it will be equal 330.24. 330.24. The second diagonal, 1928.11. Point 5 multiply in 330.24 minus 1928.11, and we close the two brackets here. It will be equal 1129.18 meter square. So this is the area of the polygon ABCD by a very easy method. Sometimes the result here may be by negative, so we always take the absolute value here and we always neglect the negative.